Hello, we're solving this physics paper 1 today. This is October-November 2021, 9702, variant 11. Okay, let's begin. Few of the content has been removed actually. We don't have electric fields anymore in AS. It has been moved to A2. So let's begin. If you like the content, remember to subscribe to the channel and like the video. This is the formula sheet. It has changed though, starting from 2022. What is essential when recording a measurement of a physical quantity? Okay, so basically a physical quantity is composed of two parts. Mainly, it needs a unit and a number. Okay, it doesn't have to be a base unit, it can be a derived unit. Like check this, 16 newtons. This is your number and this is your quantity. Okay, so we're gonna go for B. The mobility mu of electrons traveling through a metal conductor can be calculated using this equation, where E is the charge of an electron and m is its mass. The average time between the collisions of an electron with the atoms in the metal is tau. That's the time constant, tau. It's in A2 physics. What are the SI base units of mu? So mainly tau has its time, right? So it will have a unit of seconds. So mu is actually equal to E is the charge of an electron. So think about it. Charge is Q is equal to IT, or ampere seconds, divided by m is the mass, so it's going to be kg, and tau is going to be seconds as well. So we end up with ampere second square kg to the power minus 1. Ampere second square kg to the power minus 1. So B is our answer, 2B. Let's do 3 now. An aircraft heads in a direction at an angle theta east of north with a horizontal velocity relative to the air of 800 kilometers per hour. The wind blows with a horizontal velocity of 200 kilometers per hour from east to west. Okay, this is the wind velocity. So basically, how do we do these sums on relative velocity? The resultant force or the resultant velocity matters. Our aircraft is actually going kind of like, northeast, right? This is northeast, but due to the wind flowing in this direction, our resultant path is actually in this direction. All right, so this is how the wind's blowing from east to west, right? This is the velocity of the wind, and the aircraft's velocity relative to the air is actually 800 kilometers per hour. Okay, and this is 200 kilometers per hour. So since it's directly to the north, what can we say about this angle? Isn't it perpendicular or 90 degrees, right? So we can just use Pythagoras theorem to find this out. So we know opposite and hypotenuse. So sine theta is equal to opposite by hypotenuse. 200 by 800 sine inverse, that's 14.5 degrees or 14 degrees. So these are accurate. And we are going to use trigonometry to find the angle out, and to find out the resultant velocity, we're going to use the Pythagoras theorem. So 800 square minus 200 square, root over answer, that gives us a value of 775. Okay, so the closest answer is A. So 3 should be A. Moving on to 4. A CRO is used to display a sound wave of frequency 2000 Hz. The display of the CRO is shown. What is the time base setting on the CRO? So this is how you work it out. There are 4 divisions here, right? So 4 centimeters. It has a frequency of 2000. So frequency is 2000 Hertz. So time period is 1 by 2000. Okay, so 1 by 2000 is 5.0 into 10 to the power minus 4. Okay, so 4 boxes make up this time period. So 4 into time base is equal to the time period itself. So if you divide the answer, if you divide by 4, you're gonna get an answer of time base is equal to 1.25 into 10 to the power minus 4 seconds per centimeter. Now what? The answer isn't in seconds here, it's in microseconds. So if you convert seconds to microseconds, that's into 10 to the power 6, you're going to get a value of 125 microseconds per centimeter. Okay, so our answer is A. 4 is A. For 5, 4 possible sources of error in a series of measurements are listed, which are random and which are systematic. Okay, so remember that if the error is always above or below the true value, it's a systematic error. Like this, check this. It's always 5% high. And zero error is also a systematic error. You should know this, okay? You need to know this. So 2 and 4 are systematic for sure. 2 and 4 are systematic for sure, so our answer is B. And 1 and 3, an analog meter whose scale is read from different angles, parallax error, something like that. So that's random. It's totally due to the human being making an error. And a meter with a needle that is not frictionless, so the needle sometimes sticks slightly. So it will vary from experiment to experiment, not always, right? So for 6, an archer shoots an arrow at a target. The diagram shows the path of the arrow. Air resistance is negligible. The graphs show how 3 different quantities P, Q, and R vary with time. Okay. So basically, one value, this is a projectile, one value never changes. That's your horizontal component of velocity. It will never change, okay? So this is clearly the horizontal component of velocity. Clear? So P is the horizontal component of velocity, for sure. And what about Q and R though? Right? So using this information, we can get to the answer. Oh wait, in our question, it's not the horizontal component of velocity. We're dealing with displacement, right? So this is interesting. So check this out. The horizontal component of displacement, you started from here, you are going to the right all the time, okay? So horizontal displacement always increases. Think about it, you're always going towards the right. But what about vertical displacement? You went up, then you came down to your original position. You went up, then you came down to your original position. Your vertical displacement at the end of the journey is actually zero. So R must be the vertical displacement, right? And what about the horizontal displacement? It keeps on increasing as you go to the right, right? So it's actually B. Okay, so 6 is B. Hope you understand. Now let's go to number 7. Two cars X and Y. This is basically M1, right? So I'm going to teach you something. If an object is behind another one, okay, to overtake it, the object behind must have a greater speed. And also one other thing, uh, you need to equate the equations of displacement. If you equate the displacements, then you will find out when they overtake each other. And you need to consider one more thing. You need to consider the head start that the car in front has. Okay, so here we're going to use Sx is equal to Sy. Okay, displacement by x is equal to displacement traveled by y. Now y has a constant velocity of 20. Okay, so x has a constant velocity of 30. So for constant velocity, s is equal to vt, right? So 30 into t is equal to 20 into t plus 50, because y has a head start of 50 meters, right? So 30t is equal to 20t plus 50. 10t is equal to 50. T is equal to 5 seconds. Okay, t is equal to 5 seconds. So our answer should be D. Moving on to 8. A constant resultant force acts on an object in the direction of the object's velocity. Which graph could show the variation with time of the momentum of the ball? So hear me out, guys. According to the definition of force, force is the rate of change of momentum, right? So if the force is constant, right? If the force is constant, and since force is the gradient of the momentum time graph, then the gradient must also be constant. It must be a straight line. That's why the answer is C. Also, one other thing, why not D and why C? This is important because both of these are straight lines. A and B are excluded from the beginning. Why C and why not D? Because the force is acting in the direction of the object's velocity. If it said that the force was acting in the opposite direction to the object's velocity, it would have been c. But since it's acting in the same direction, it will be in a positive nature, positive gradient. Okay, which statement must be true for an object in a gravitational field? If the object has mass, then the field causes it to accelerate. Not always. If the object has mass, then the field causes it to have weight. This is true. So basically, C and D were wrong because this statement doesn't make sense. Hear me out. If an object is on the ground, does it accelerate? No, right? Maybe if it's airborne, it would have accelerated, but when it's on the ground, it doesn't accelerate, but it does have weight, okay? So having mass results in having a weight. For number 10, we have a ball of mass 0.16 kg. It is traveling horizontally at a speed of 20 meters per second. It collides with a wall and rebounds with a speed of 15 along its original path. The ball is in contact with the wall for a time of 1. So force is the rate of change of momentum. Let's find out the change in momentum. So this was the scenario. It hit the wall like this, then it rebounded back, okay? It was traveling at 20, rebounded with a speed of 15. So the change in momentum actually is 15 into, if I take this to be positive, this is negative, okay? So 15 into 0.16 minus 20 into 0.16, okay? And the time taken will be 1 millisecond, or 1 into 10 to the power minus 3, okay? So 15 into 0.16. So the minus thing, people tend to forget because the momentums are in opposite directions, right? And there is a minus sign inherently, final momentum minus initial momentum. So the minus actually turns into a plus, okay? So 20 into 0.16, we get 5.6. 5.6 by 1 into 10 to the power minus 3. Let's solve this. I'm getting a value of 5,600 newtons, and that should be the answer. 10 is D. Just check the mark scheme. Moving on to the second section of the video, 11 to 20. Remember to subscribe, guys. It will help me a lot. I'm trying to get to 1,000 subs. The channel is growing. A uniform soil block is fully submerged in a tank of water. The dimensions of the block are x and y as shown. The block is held vertically in the positions shown. The density of the block is the same as the density of the water. If the block is always held at the same depth below the surface of the water, which single change would increase the magnitude of the upthrust? Check this out, guys. Upthrust is equal to V rho G. So remember that this V is the volume of the block, rho is the density of the liquid, and G is the value of the gravitational field strength. Now, to decrease the value of upthrust, we either need to decrease the volume, decrease the density of the fluid, or G. So holding it horizontally wouldn't change the volume. Decreasing the density of the block doesn't make sense because it doesn't appear in the equation, okay? If this said decreasing the density of the fluid, that would also be wrong. Oh, we want to increase the magnitude of the upthrust. Sorry, my bad, guys. So we need to increase these values. Either any dimension or volume of the block, the density of the fluid, or G. Okay. So increase the density of the block. This is wrong. The block has nothing to do with it, guys. If it said increase the density of the fluid, it would have been the answer, but C is the best answer. If you increase dimension Y, volume increases and upthrust will also increase, okay? Moving on to 12, a shelf XY is 0.40 meters long and is attached to a wall at end X. It is kept horizontal by a wire attached to Y and to the wall as shown. The tension force in the wire is 50 newtons at an angle of 30 degrees to the horizontal. What is the moment of this force about point X? This is the pivot. This force has two components, the horizontal component and the vertical one. You cannot take the horizontal component as it passes through the pivot. Any force passing through the pivot does not give any moment about that pivot, okay? So I was planning to do some videos on AS physics content. If you do want those, just comment below. I'm just gonna do some then on specific topics like momentum, etc. Like short videos. I did some for chemistry, so just like that. So we're gonna take the vertical component, which is 15 sine 30 into 0.40, right? Let's do this. 15 sine 30 into 0.4, that gives us a value of 3 Newton meters. So 12 should be A. Clear? A statement about the principle of moments with some words omitted is shown. For an object in a state of rotational equilibrium, the sum of clockwise moments about any point is equal to the sum of anticlockwise moments about the same point. Okay, really important. We're talking about the same pivot, the same point. A bird dives to a depth of 1.5 meters below the surface of a lake. Atmospheric pressure is 101 kilopascals. The density of water is 1000 kilograms per meter cube. What is the pressure at this depth? Okay, so pressure is equal to h rho g, where h is the height of liquid above you. Okay, so since the bird is 1.5 meters below the surface, it's 1.50 into 100 into rho 1000 into 9.81. So hear me out. This is the surface of the liquid, and the bird is 1.5 meters below. Now, you guys need to understand that there's also air pressure acting at the top of 101 kPa, right? So to find out the total pressure, you're going to find this out first, 1.5 into 1000 into 9.81, right? But this is just due to the liquid. To find out the total pressure, you need to add this 101 into 10 power 3 plus 14715, okay? Plus 101 into 10 power 3. We're getting an answer of 115715. So that's 116 kilopascals. I'm going to go with D, and 14D is correct. So for 15, which statement about energy is not correct? When they say energy is never lost, right, but it may be transferred between different forms, that's true. Okay, this is true. Energy can never be lost. They mean energy can never be destroyed. Okay, but it may be transferred from different forms. So this is correct, and it's not the answer. In an elastic cohesion, the total energy is constant. Yes, kinetic energy is lost, but it may be converted to heat, sound energy, but the total energy is constant. So this is also true. For the efficiency, the ratio of useful energy output to total energy input, this is also correct. So it's not the answer. When a machine does work, friction reduces the total energy. No, this is not correct, because yeah, work is done against friction, so some energy is lost as heat, but total energy, the sum of useful plus wasted energy, remains the same. So 15 is D. This is not correct. The other three are correct. A pull of radius 0.40 meters supports weights of 20 newtons and 50 newtons by means of a thin string as shown. The weights are moved by slowly rotating the pulley clockwise through an angle of 60 degrees. What is the increase in the total gravitational potential energy of the weights? Interesting. So they're saying that we rotate the pulley clockwise by 60 degrees. That means to the right. It's being rotated to the right. So if it rotates to the right, what's going to happen? This one will go up and this one will go down. Basically, that's what's happening, right? Although tension is directed upwards. So this side goes up and this side goes down. All right. So we need to find out the distance moved actually. So I think we just have to use circular measure, P1, basically pure math. Um, we know the radius, right? So 60 divided by 360 into 2 pi r. 60 by 360 into 2 pi into 0.40. That's the distance moved. 60 by 360 into 2 pi into 0.4. This is the distance moved. 2 by 15 pi or 0.419 meters. All right. Now, if you guys want to find out the change in GP, the gain is mgh minus loss mgh. So gain is 20 into 0.419 and the loss is minus 15 into 0.419. Okay, answer into 20 minus answer into 15. I'm getting an answer of 2 by 3 pi or 2.09, which is rounded off to 2.1. So the answer is actually C. Okay, a car of mass 1500 kg accelerates from an initial speed of 15 meters per second. This acceleration causes the car to gain 3 into 10 power 5 joules of kinetic energy. What is the change in the speed of the car? Okay, so basically half m v square minus u square is equal to the gain in ke, right? So half into mass 1500 into v square minus 15 square is equal to 3.0 into 10 to the power 5, okay? 3 into 10 to the power 5 into 2 by 1500 plus 15 square root over answer. So I'm getting a value of v square equals to 625 and v is equal to 25 meters per second. Okay, so this is actually the final speed. Okay, this is the final speed of the car. Now they want the change in speed of the car. So what's the change gonna be? The change in speed is actually equal to 25 meters per second minus what was the initial speed? 15. So the change is actually 10 meters per second. That's why the answer is B. 17 is B. Alright. Moving on to 18, a car of mass 1500 kg travels at a constant speed of 30 meters per second down a slope. The slope is at an angle of 6 degrees to the horizontal. What is the magnitude of the total resistive force acting on the car is 2000. What is the power output of the car's engine? Okay, so the weight is acting like this. It has a component down the slope. So two things are working against this resistive force: weight and the power of the vehicle. Okay, so the driving force plus the component of weight, mg sine theta, 1500 into 9.81 into the component sine 6 degrees, is actually equal to the resistive force 2000. And we know that p is equal to mv since it's constant velocity, and driving force is equal to power by constant velocity. So power by 30 plus 1500 into 9.81 into sine 6 is equal to 2000. Got it? So P is actually equal to 13855.9 or 13.8 kilowatts. I'm assuming 14 kilowatts, 18 should be A. Moving on to 19, a metal wire of cross-section area A and unstretched length L is subjected to stress sigma. As a result, it has strain epsilon. Which expression gives the Young modulus of the metal? So, hear me out. Young modulus is equal to stress by strain. You guys know that. So, basically, Young modulus is equal to sigma by epsilon. Is that it? Oh, that's it. So 19 is C. Okay. So sigma by epsilon. Okay, cool. So number 20, I have this done. Two identical springs are connected in parallel. A weight of 8 newtons is hung from the combination as shown. The graph shows the variation with length of the force applied to one of the springs. Careful, okay? So if we apply a force of 8 newtons to one of the springs, what happens? The length changes from 4 to 10 centimeters. So what actually happened to the extension if we apply the 8 Newton force to one spring? It goes from 4 to 10 cm. So the extension is actually 6 centimeters. Okay, that's for one string. Now, what happens if the same weight is shared by two springs? The logic is if two springs, identical springs, are arranged parallelly, then the weight is shared among them and the extension becomes halved. It becomes half of the original. So the original one was actually 6 centimeters, but the new extension will now be 3 centimeters. Are we clear? So if we want to find out the energy in one of the springs, we know that energy is equal to half Fx, right? The energy is equal to half Fx. So since the 8 Newton force is shared between two of them, it will be halved equally. So it's actually going to be 4 newtons instead. So half Fx or 0.5 into 4 into the extension of 3 centimeters or 3 into 10 to the power minus 2 we're getting an answer of 0.060 joules. So 20 is A. Interesting question, okay? So this should be the new position because it's actually getting a force of 4 newtons rather than 8. It's shared, right? So the extension is 3 cm. Two balls float on the surface of the sea. The balls are separated by a distance of 1.30 meters. A wave travels on the surface of the sea so that the balls move vertically up and down. The distance between a crest and an adjacent trough of the wave is 0.90 meters. What is the phase difference between the two balls? Okay, so the distance between the crest and trough is 0.90. So crest to trough is 0.90. Then crest to crest will be double that, 1.80 meters. So 1.80 meters is actually 360 degrees, right? One whole wavelength is one complete phase difference of 360 degrees. So what about 1.30 meters? It's going to be 360 by 1.80 into 1.30. So 360 by 1.8 into 1.3, we're getting an answer of 260. Okay, 260. So the answer is D, 21D. Which statement about transverse or longitudinal waves is not correct? Longitudinal waves can be used to demonstrate diffraction. Okay, sure. Sound can be used. Longitudinal waves can travel in a vacuum. No, only transverse waves can do that. Sound needs a medium to travel, right? A glass tube. So B is the answer because it is not true. And yeah, these two are correct. A glass tube is closed at one end and has a loudspeaker at the other end. A station wave is formed with a node at the end, at the closed end of the tube, when the sound has frequency f0. There are no other nodes. Okay, so the only node we have is here. So remember guys, if in glass tubes you need to know about two patterns, if both ends are open and if one end is closed. So if one end is closed, the pattern goes like this. Okay, this is basically the pattern. And if both ends are open, this is the pattern. Okay, like this. So since one end is closed, we're going to look at these patterns, and we only have one node, right? So we're going to opt for this pattern. Super hard to draw, like this basically. Okay, here, got it. Now the frequency of the sound is then slowly increased. This is the initial one, this is the first one. What about the second one? The second one is going to be like this. It's going to be like this basically, right? This is the second pattern. So for the first pattern, what's the situation actually? This is a node and this is an antinode, right? So node to antinode, that's lambda by 4. Okay, so L is equal to lambda by 4. The length of the tube, L, is equal to lambda by 4. So lambda is equal to 4 times L. And we know that V is equal to F lambda, right? Or we can say that V is equal to F times 4L. Okay, this is the first scenario. Now as we increase the frequency, what's gonna happen? We're gonna get the next pattern, something like this, right? I just told you guys. So now what's happening? This is a node, this is another node, and this is an antinode, and this is another antinode here. So lambda by 4, lambda by 4, lambda by 4, or 3 lambda by 4. In the second scenario, it's length is equal to 3 lambda by 4, and lambda is equal to 4L by 3. This is the new lambda. Now the logic is you need to keep this value constant, okay? The value of velocity, because velocity is not going to change. We need to keep it at 4FL. So V is equal to the new length becomes the new lambda becomes 4L by 3. Now what do we need to do to the value of frequency to make sure that the value of 4FL is maintained? Frequency needs to be multiplied by 3 times the original value, right? Then the 3's can cancel out. We're gonna get V is equal to F0 into 4L. So frequency will actually increase by 3 times. So 23 should be D. Sorry for the elaborate explanation, but basically the pattern goes like this. This is f naught, this is thrice f naught. We're gonna get 5 times f naught afterwards, okay? But for here it's like f naught, 2 f naught, 3 f naught, okay? It's just integer multiples, but there we have odd numbers, okay? It's a bit weird. So with which waves can the Doppler effect be observed? Basically all waves, okay? This was a trick question. The answer is A. Which radiation could consist of waves of wavelength 0.5 nanometer? Okay, so you guys need to memorize something actually. Why don't I show you guys? So this is basically what you guys need to memorize. Wait, here you go. This is what you guys need. So this is the ultimate sheet for you know electromagnetic radiation. It's a GX-UV-IMR. That's how I memorize. It's a mnemonic. GX-UV-IMR, GX-UV-IMR, gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, radio waves. Um, this is in the order of increasing wavelength and decreasing frequency. Gamma rays have the highest frequency, basically. All right. So you just need to remember that visible light is at 400 to 700 nanometers, okay, or 10 to the power minus 7 meters. Now, as you go from one form to another, like if you go from visible to infrared, basically that 10 to the power minus 7 becomes 10 to the power minus 5, okay? It changes by 2 typically. So from infrared to microwaves, it's going to be 10 to the power minus 5 to 10 to the power minus 3 or minus 2, and radio waves are like 10 to the power 1 ish, or just 10 to the power 0. And if you go backwards, ultraviolet is 10 to the power minus 8, x-rays are 10 to the power minus 9 or minus 10, and gamma rays are at like minus 14, okay? So now let's match this with the information that's given over here, right? Um, 0.5 nanometers. 0.5 nanometers. So basically, if you look at this, nanometers means 10 to the power minus 9. Let's do this. 0.5 into 10 power minus 9. That's 5 into 10 to the power minus 10. Now I just told you visible light is at 400 to 700 nanometers, or like 4 into 10 to the power minus 7 to 7 into 10 to the power minus 7, okay? Now ultraviolet, it's a bit different. It's at like 10 to the power minus 8. Ultraviolet is actually a very small region, okay? It's a very small region, like we can't fit in much, okay? Now X-rays. X-rays are like 10 to the power minus 9 to 10 to the power minus 10-ish, okay? So this fits the criteria. 25 should be D, okay? So for 26, a string is fixed between point P and an oscillator M, and the string is fixed between point M and point Q. M is midway between P and Q. The frequency of the oscillator is adjusted until a station wave is formed on both strings. The speed of the wave between P and Q is twice the speed of the wave between M and Q. What? Sorry, the speed of the wave between P and M is twice the speed of the wave between M and Q. Okay. Which diagram could represent the stationary wave pattern? So basically we are getting a node at M. That's the basics. And it won't be symmetrical, okay? It would only be symmetrical if they traveled at the same speed. Then we'd get something like B or D, okay? But since it's asymmetrical, and the wave on the left hand side is traveling at a greater speed, think about it. V is equal to f lambda. So since speed is greater, frequency must be greater, right? And lambda must also be greater. So since this one over here has twice the velocity compared to this, logically, if you think about the wavelength, it's also going to be greater. Basically, since it has greater speed, it travels the same distance in shorter time. So basically, think about Q. Q takes 2 oscillations to travel to M, but P only takes 1 oscillation. That's why A is the best answer. Do you guys get it? That's the logic behind this. 27. A water wave in a ripple tank is diffracted as it passes through a gap in a barrier. Which two factors affect the angle of diffraction? Mainly, guys, remember it is the width of the slit and the wavelength of the the wavelength of the incident wave. So that matches with 27, D. Okay. So let's go to 28. This is a difficult one. It's kind of tricky. Light of wavelength lambda is incident normally on two narrow slits S1 and S2, a small distance apart. Bright and dark fringes are observed on a screen a long distance away from the slits. The nth dark fringe from the central bright fringe is observed at point P on the screen. Which equation is correct for all positive values of n? So guys, this is the figure on the right. As you can see, the pink lines represent the maxima. So at 0, I'm talking about this point over here, when both the waves actually travel the same distance, path difference is actually 0, right? So when path difference is 0, you guys know that constructive superposition occurs, right? So you're going to see a maxima. And just a bit above and below to that point, the path difference will be 0.5 lambda. As you can see, I've marked it with a purple color here. For 0.5 lambda, we actually have destructive superposition. We're going to see a minima followed by lambda again. Okay, followed by lambda. So at lambda, that's the at 0, it was the central maxima. Then we have the first sub maxima, right? Then the second sub maxima or subsidiary maxima, and it goes on. So we're going to see a pattern of fringes with some gaps between them, right? So maxima, minima, and so on. So basically, they want an equation for all positive values of n, where n represents the dark fringes. So basically, think about it. Think about it logically. Lambda by 2 will be our n equals to 1. 3 lambda by 2 or 1.5 lambda, right? That's the next minima. This is the pattern for minimas, okay? It's zero point 0.5 lambda, 1.5 lambda, then 2.5 lambda, and so on. It keeps on going. So just like that, n is equal to 1, n is equal to 2, and n is equal to 3. That's the third minima. So we want to find out a formula that is actually valid for all positive values of n. So why don't we try trial and error? Okay, that would give us the best answers. So let's start. Starting with this S2, which is a longer distance, p minus S1 p is equal to n lambda by 2. So all positive values of n, that is the key point here. Okay, no, 0 isn't allowed. So let's try 1 into lambda by 2. That's fine, lambda by 2. 2 into lambda by 2. That's actually lambda, which is for constructive superposition. So this is wrong. Okay, let's move on to the next one. N lambda, 1 lambda. It's wrong at the beginning. Okay, so it's not working. For C, take this 1 minus half lambda, which is half lambda. Good. Then 2 minus half lambda, which is 3 by 2 lambda. Then 3 minus half lambda, which is 3 minus 0.5 is 2.5, or 5 by 2 lambda. Okay, so it fits the criteria. This looks good. C is the answer. Now what about D? Why is it not correct? Basically, if you use 0, it would have been correct, but this says all positive values, so you cannot use 0. You got to start from 1. If you start from 1, let's go 1 plus half lambda, that's actually 3 by 2 lambda. You're missing the first value of your sequence, which is 0.5 lambda. That's why it's wrong. Clear? Now let's go to this 29. Green light is incident normally on a diffraction grating and forms a diffraction pattern on a distant screen. Which change on its own would it decrease the separation of the this diffraction maxima on the screen? Okay, so we know that d sine theta is equal to n lambda. So remember that we want to decrease the separation of the maxima, or we want to decrease the value of theta. So our goal here is like to decrease the value of this fraction. How? Either by decreasing the numerator or increasing the denominator. Okay, so if you actually increase, this has nothing to do with this. This was just a trick. This doesn't appear in the formula. Replace the diffraction grating with a grating that has smaller separation. This is wrong. If you replace it with a smaller separation, the value would actually increase. Replace the diffraction grating with a grating that has fewer slits per unit length. What does this mean? This is actually capital N. Now hear me out. There's a formula between D and capital N. D is equal to 1 by capital N. So if you replace it with one that has fewer n, the value of d will increase. And if d increases, the value of fraction, the fraction decreases, and theta also decreases. Get it? That's why the answer is C. And red light actually diffracts more. Okay. What is meant by electric field strength? 30, 31, these are not in our syllabus anymore. Going to 32 directly. The current I in a wire is given by the equation I is equal to NAVQ, which relationship is not used to derive this equation. Q is equal to IT, distance equals to speed into time, number is equal to number density into area, volume is equal to length into area. Clearly we don't use C, okay? Remember the derivation, it's important for P2, okay? Paper 2. We do use Q is equal to IT, and we do use distance is equal to speed into time, okay? And volume is equal to length into area. We do use those. How? I'm just going to show you in short. Basically, we have a conductor like this of cross section area A, and current passes through it, right? So the volume of this is actually cross section area into length. So each charge carrier has a charge of Q, and the number density or the number of charge carriers per unit volume is actually n, number of charge carriers per unit volume. So each charge carrier has charge Q, and how many charge carriers are there? You can actually find it out by multiplying n into v. That gives you the number of charge carriers. So Q into nv, and v can be written as al. So Q into NAL. This is the total charge flowing through, right? Now we know that Q is equal to IT, and I is equal to Q by T. So I is equal to QNAL by T. Now look at the distance. The distance is L. Distance by time. What does that mean? QNAV. V is the drift velocity. That's how we get it. Okay, so that's 32. 33. A circuit contains two resistors P and Q and a power supply of negligible internal resistance as shown. The circuit in resistor P is 2 amperes and the power dissipated by resistor P is 18. Okay, so it's series 2 amperes over here, 18 watts. We know that P is equal to IV for Q. So 18 is equal to 2 into V. V is equal to 9 volts. Okay, 9 volts. Now for Q, it dissipates. We know that voltage equals to work done by charge, right? So the work done is actually equal to, the voltage is actually equal to 240 by 40, or just 6 volts, right? So this is 6 volts. It's a series circuit. You can add them up. 6 plus 9 is equal to 15. The answer should be D, 33D. The IV characteristics of two components are given. So P is a ohmic resistor and Q is a semiconductor. For a current of 0.5 ampere, the power dissipated in Q is double that in P. P is equal to IV. So for P, that's 0.5 into 2. For Q, that's actually 0.5 into 4. So 1 and 2. The power dissipated in Q is double that of P. This looks good. 34 is A. I'm not going to look at the other ones. This is how you save time, okay? But you can still check them out if you have like problems. Like if you just want to be sure and you have a lot of time. But if you're lacking time, just go for the one you're confident with, okay? But it's best to check when you go through the second review, right? Two copper wires, S and T, of equal length are connected in parallel. Wire S has a diameter of 3 millimeters. Wire T has a diameter of 1.5 millimeters. Okay. A potential difference is applied across the terminals of this parallel arrangement. So we have two wires S and T over here. They're connected in parallel. They have the same length, but S has a diameter of 2D while T has a diameter of D. So we know that R is equal to rho L by A. They're of the same material, right? Both of them are copper. So R is equal to rho L by pi d square by 4, or R is equal to 4 rho L divided by pi d square. So this is for T. What about RS? It's going to be rho L divided by pi into 2d by 2 whole square. So resistance of S is equal to rho L divided by pi d square. Okay, rho L by pi d square. So if you compare the resistance of S and T, what are we actually seeing? The resistance of T is actually 4 times that of S. Okay, so if S has a resistance of R, T has a resistance of 4R. Okay, and since it's a parallel connection, both of them have the same voltage. We know that V is equal to IR, I is equal to V by R. Now if you look at the ratio IS by IT, we're going to end up with V divided by resistance of S, which is just R, divided by V divided by resistance of T, which is 4 times R. We can get rid of V and we can also get rid of R, and if you do the reciprocal properly, 4 is going to come up. That is why the answer is D. The ratio is 4. Okay, now what is the circuit symbol for an oscilloscope? Okay, so this is quite important. Basically, in your syllabus and in your coursebook, you're going to see the symbols for all the components. Okay, so you need to remember that. So 36, the answer is actually C. Now if you want to see the other components, you can look at them from the syllabus. Wait, let me show you. Do I have it here? I don't think so. Wait. Okay, so here we go. This is the syllabus and we have the content here. Okay, so here you go. So you need to learn all of these. Okay, so the first one we saw was for a microphone. Okay, this is for an AC power supply. This is for an oscilloscope, right? And this is for electric bell. Okay, what was the last one though? Yeah, it's basically an electric bell. Okay, so you need to learn all of these, so make sure you learn them properly. They can come at any moment. Okay, so good luck with that. Also, I just want to check something. Variant 1.3 is different, right, from 1, 2 and 1.1. Yeah, this is unique. Okay, for 37, 37 is a tricky one, along with 38 as well. Let's be careful with 37. We have 3 identical cells, each of the electromotive force E and internal resistance R. They are connected as shown. So what is the potential difference between points X and Y? Interesting. The correct answer is actually 0. Okay, the correct answer is 0. Let's try to understand why. This is really important, so focus. So basically we have 3 identical cells, each of electromotive force E and internal resistance R. All of these are actually internal resistors. You need to understand that at the beginning. Now hear me out. Let's look at the polarity. Okay, the positive end is connected to the negative one, the positive end is connected to the negative one, positive is connected to the negative one. Great. So if we want to find out the total EMF of the circuit, it's going to be 3E. We add all of them up. What about the total resistance though? What's the total resistance? It's 3R, right? So if you want to find out the current, it's actually going to be 3E divided by 3R, or just E by R. Now let's see something interesting. If you actually connect, so I just want to say something. I don't know if you guys have done practicals or not. If you ever connect the voltmeter or the multimeter across parallel to the battery, you know what? You're never going to get the battery reading. Suppose the battery was rated at 5 volts. You would never get 5. You're going to get something like, you know, um, 4.8 or something. Okay. Why? Because some energy is lost. Some energy is lost in the wires as heat, and also not in the wires actually. If we're talking about the battery itself, some energy is lost in the battery as internal resistance. Okay, so the interesting thing here is that there are no external resistors. Do you guys understand? We only have internal resistors. So if we did have an external resistor here, somewhere here, maybe it would get a lot of voltage. But here's the thing, when you don't have external resistors, basically you might not end up with any terminal PD. All the volts will be lost. And you can think of it that way, this way, like if this is battery 1, this is 2 and 3. Basically the resistors of batteries 2 and 3 are acting as external resistors for battery 1. So they're gonna take away voltage. Do you get it? So basically what's happening here is that we have 3E and all the resistors are identical here. The EMF 3E, you know that when resistors have same resistance, EMF is shared equally between them, right? So three of them are gonna share equally. This R is gonna take away E, this R is gonna take away E, and this R is gonna take away E. So 3E minus E minus E minus E, you're gonna end up with 0 volts, 0 terminal PD at the end, okay? Now, what about this answer? If we connect the voltmeter between terminals X and Y. So check this out. You connected the voltmeter across this battery. Now this battery is supplying out E and resistor R is also taking away E. So what's the end result? You're gonna get a value of 0. That's how we got this answer, okay? So hopefully you guys understood. Okay, let's go to the next one. 38. Potential differences across two resistors of resistances R1 and R2 are compared using a potentiometer. Remember, the function of a potentiometer is to compare voltages or EMFs, okay? Now, one terminal of a galvanometer is connected to point X. The other one, oh, the galvanometer reads 0 when its other terminal is connected to a point that is at a distance 60 centimeters from one end of the potentiometer wire. Okay, so basically, one terminal is connected at X and the other end is connected at a distance 60 centimeters from the beginning of the potentiometer. On the other hand, one terminal of a second galvanometer is connected to point Y and it reads 0 when its other terminal is connected to a point that is a distance of 80 centimeters from the same end of the potentiometer wire. Okay, so you guys need to understand something, how a potentiometer works. Basically, we are comparing this voltage with this one over here. This is one circuit. On the other hand, we are comparing this section of the wire, this section that's getting the voltage with R2. It's not like we're gonna consider the whole thing for R2, only the section between the two, you know, crocodile clips, the terminals basically, okay? So if you think about it, you guys know that V is equal to IR, and this is a series circuit. It has IR, like constant current, and you guys know that the more the resistance, the more voltage a particular section will get, right? And we can say that the voltage of this wire is equal to the voltage of R1 since the galvanometer reads 0, and the voltage of this section 20 centimeters is actually equal to the voltage of R2. Okay, and we also know that R is equal to rho L by A. So the greater the length, the greater the resistance. So the green wire, length of wire, has more resistance and it will also take in more voltage compared to the pink wire, okay? So since voltage is proportional to resistance and resistance is proportional to length, we can also say that voltage is proportional to length, right? So we can actually say that 60 centimeter is equal to R1 and 20 centimeter, not 80, is equal to R2. So if you do this ratio, right, R2 by R1, what are we gonna get? 20 by 60, or that's 1 by 3. So 38 is actually A. Okay, great. 39. A uranium 238 nucleus undergoes a series of nuclear decays to form uranium 234. Which series of decays could give this result? Okay, U238 92 to uranium again. But our mass number has decreased by 4. This only happens during alpha decay. Okay, so remember, this decrease in mass number happens when there's alpha decay. Then to get back to the normal, to get back to the same isotope, to an isotope of the same element, you need 2 beta decays. Okay, so hear me out. After alpha decay, what's going to happen? We're going to end up with element X 234 90. Then after 1 beta minus decay, it's going to be Y 234 91, and then after another beta minus decay, it's gonna be uranium again 92 234. So what did we need actually, guys? 1 alpha and 2 beta minus. Okay, really important. 39 is C. This was in the March paper as well, 2022. Which combination of up down forms a proton? This is just memorization, up down. Okay, so 40 should be B. So that is all. I'm gonna complete the series, ON series 2021 series completely, right? And after I'm done with them, I'm gonna link ON 2021 variant 1 2 over here, ON 2021 variant 1 3 over here, and I'm gonna link the playlist for paper 1 up here. All right, and make sure to subscribe to the channel, and catch you guys in the next one. Okay, see ya.